video, we're going to talk about car loans. A loan that you pay off by making monthly or weekly payments is called an installment loan. A fixed installment loan consists of equal payments for the entirety of the loan. Loan payment formula for fixed installment loans is here below. What you can see is we have PMT, which is the payment, is equal to P, the amount of the loan, times R over N, where R is the interest rate, and once again we're going to write that as a decimal. Then N is going to be the number of payments per year. This is usually just going to be 12. We're going to make monthly payments. Then we have divided by. So we have this big denominator, that's 1 minus, I have parentheses 1 plus R over N, and then that's raised to the negative NT. So let's take an example and use this. So example 1, find the monthly payment for a $12,000 loan for 5 years at 8% interest. Once we find the monthly payment, then we're going to find the total amount of interest paid for the loan. So let's go back to our formula. The PMT is P times R over N divided by 1 minus 1 plus R over N to the negative NT. So I'm going to plug in all of those pieces. So the P is 12,000, that's our loan amount. The R is 0.08, and it is going to be monthly, so I'm going to divide by 12. And you can see that I did the same thing on the bottom, 1 minus parentheses 1 plus 0.08 over 12 to the negative 12 times 5. When you put this in your calculator, this is a lot. So you definitely want to make sure you're using your parentheses. You want to make sure that you do whatever work you can ahead of time. So like that negative 12 times 5, you know that's negative 60. So let's just put in negative 60. And then here in the bottom, where I have 1 minus 1 plus 0.08 over 12, because it's a denominator, it really needs to have parentheses there too, or your calculator doesn't know what to do. So lots of pieces to this particular equation. It's really complicated. You want to pay attention to how you put it in. And really right now I do want you to stop, put this in, see if you can get this number, because I do think it's a lot of steps, right? And if you don't like that, if you don't like all those steps, I have a detour. So this detour is you could do the same thing using Excel. So I just want to step us through the way to do that. And I think you're going to find that it's a lot easier. So in Excel, for it to do math, like to know that it's going to use an equation's already in it, you have to find this fx. So it's kind of like saying a function. So that's what I'm showing you in this little picture is the fx. So you're going to hit that first. When you hit that, it's going to give you some choices. So the first thing I did is I went right here to select a category, and the category I went to is financial because that's what we're doing. And then you scroll through until you find PMT, which you can see right here. Now notice down here, it gives a description. So if you want to do other formulas that we've talked about in this chapter, you can go back and look at those as well. But I like that it already tells you, here's what it's going to do. It's going to calculate the payment for a loan based on constant payments at a constant interest rate. And then it tells you the things it's going to need to know, the rate, the NPER, PV, FV, and type. And I'm going to show you all of those. So the first thing it needs is the rate. So for the rate, you have to put in the interest rate and then you divide by how many payments you're going to make a year. So note that you have to put the percentage in. So see how I put 8% over 12? And if you ever forget, it gives you, again, in the explanation, what to do. So that's the first thing I do. I put 8% over 12. And then I go to the NPR. So NPER says what's the total number of payments. So it's not how many payments a year, it's how many payments in total. And you can see that again right here. It gives an explanation. Luckily, this is like it's a computer, right? So it has a program. It can do math. So you don't have to say, oh, I know 12 times 5 is 60. You can tell it 12 times 5 and it'll calculate that that's 60. PV means what's the amount of the loan. Notice, don't put any commas in there. It'll tell you error, so you just want to put it in exactly how it is. So I put in 12,000, and the future value is 0. We're trying to pay the loan off. Immediately, you can already see the answer is there. So I put in the present value, the future value, and then there's this last category that says type. Leave it blank. It tells you if it's beginning, end, whatever. Just leave it blank. That's the easiest thing to do. And then it pops in 243.32. Again, round to 2 decimal places because this is money. It gives it in red. I didn't tell it to do red. Red means it's going to be a payment. So there are things within Excel that say negatives or positive based on if you're getting money or spending money. Definitely we are spending money. And we got the same 243.32 we did by using the calculator. So totally this is up to you. I love that Excel does this. I do think Excel is a program people use a lot at work and in the real world, so I would say this is an awesome choice for you for this section. And of course, I'm fine with you using it for all of the work I give you for this chapter. All right, so let's go back to our example. So either way we did it, we got $243.32 as our monthly payment. So my second question was find the total amount of interest paid for the loan. So to get the total amount of interest for the loan, I need to figure out, well, how much did I pay in total for the loan? So I'm going to take my total payments and subtract my loan amount. So my total payments is the $243.32 that we paid every month for 60 months, and then we have $12,000 that we paid for the loan. So when I subtract these, I get $2,599.20. So let's try this again. Example 2, I want to finance $34,000 for a car. I have an $8,500 down payment, and the car dealership offers 2 financing choices. So choice 1, 4 years at 5% interest. Choice 2, 6 years at 6.25% interest. For each of these cases, we're going to figure out how much we would pay a month, then how much we would pay in total for the loans, and then figure out which one's less expensive and by how much. So let's start with the $34,000 for the car with an $8,500 down payment. Tells me how much is the loan going to be. So the loan in both cases, option 1 and option 2, is we're going to finance $25,500. Okay. So I'm putting this into option 1 and option 2 into the original big equation that we had. So you can see I have the $25,500 as our P. On option 1, the interest rate was 5%, so I put 0.05. Always monthly, so divide by 12. And on the bottom, because it's 4 years, you can see I have that negative 12 times 4. Okay. On the right side, same thing. The only difference is the interest rate now is 6.25%, which I wrote as 0.0625, and then 6 years. Great. Again, I encourage you, try this in your calculator. Pay attention that you are putting parentheses in the denominator and that you're multiplying this out ahead of time and you're putting in negative 48 or negative 72. Okay, so I got that the 4 years I pay $587.25, but for 6 years I pay $425.62. Again, if you didn't like these methods, I'm showing you here's what I put in for each of them in Excel. So the 5% over 12, the 4 times 12 for payment, the present value, the future value 0. I left the type blank and you can see the $587.25. Option 2, 6.25% over 12, 12 times 6 for the number of payments, same present value of $25,500 and the future value of 0, and you can see $425.62. So your choice, whichever way you want to do it. So we can see those were our payments. So now we want to say how much do we pay in total. So for option 1, we're making 48 payments. For option 2, we're making 72. So you can see I take the payment times the number of payments, the payment times the number of payments. So in option 1, I paid $28,188.96. In option 2, I paid $30,644.64. So the difference in interest, we're going to look at in a minute, but first let's say how much interest do we pay with each of them. So for both of the cases, we're going to take the total amount we pay and subtract the amount we financed. So for option 1, there's a $2,688.96 payment of interest. And in option 2, there's a $5,144.64 payment in interest. When you're looking at these and seeing that there is a big difference between the two, between option 1 and option 2, I subtracted these interest amounts and found there's a difference of $2,455.68. So it is cheaper with going with option 1. I think that's fine. I think you need to be realistic as you're thinking about this. You're like, well, why would I take option 2 over option 1 if I know I'm going to pay more with option 2? It's just a difference in what can you afford every month. $587 is a lot of money. $425 might be more doable. So even if you pay more in the long run, it's can you afford it at the time that you take the loan. Along with just paying for the car, there are cost of ownership. So let's look at that. So I'm giving you 2 different cars, car A and car B. That says the average cost per mile for operating car A is 28 cents a mile, and then the cost of ownership is 53 cents. which gives a total of 81 cents per mile for having car A. Car B, very similar. It has a cost of ownership of 19 cents for operating and 36 cents for ownership, so there's a total of 55 cents per mile for ownership for car B. So let's say we drive an average of 18,000 miles per year. How much more will we spend on car A than car B over a 4-year period? All right, so we're going to start by just looking at how much would we spend per year. So if we went 18,000 miles a year and there was 81 cents per mile for car A, I have 0.81 times 18,000 says I'll spend $14,580 a year. I multiply it by 4 years, so I spend $58,320 over the 4-year period. For car B, it's a little bit less. It's 55 cents per mile, so I multiply that by 18,000 miles. It tells me $9,900 a year. So I multiply that by 4, and it says I spend $39,600. Definitely a difference between these two. So when we subtract them, as I did right here, car A is going to cost $58,320 minus $39,600, which is $18,720 more in operating cost. Okay. Another thing to think about when you're looking at cars is which one's more fuel efficient. So let's say we want to know how much will we save in gas per year if we buy a hybrid car that gets 42 miles a gallon versus a car that averages 28 miles per gallon, given that we drive 15,000 miles per year and gas averages about $2.85 per gallon. So let's do side-by-side comparisons. And so with the hybrid, if we drive 15,000 miles per year, then we will buy 15,000 divided by 42, which I had to round to 357.14 gallons of gas. So I'm taking the total miles divided by the miles per gallon to figure out how many gallons I need to buy. And then I multiply that by the price of gas. So the $2.85 per gallon times 357.14 gallons says there's $1,017.85 a year in gas. The car only gets 28 miles per gallon. So when I divide 15,000 by 28, that's 535.71 gallons of gas. I multiply that by 285, which gives me $1,531.90. So my difference is just subtracting those two amounts. The 1531.90 minus 1017.85 gives me $514.03 savings by getting a hybrid car.